Hello students, in this video we are going to learn how fast multiplication can be accomplished by carry save addition. In fast multiplication, we already know two methods are there. We have already seen how Booth's algorithm by bit pair recoding. In this carry save addition, the intermediate carry can be avoided. The reason is if you are multiplying two numbers, these are all the partial product. When we are adding these numbers, the carry can be generated. If the number of bits are increased, we have more number of partial product and the size of the carry can also increase. That can occupy more memory space. It leads to increase the fetching time. So the overall addition process can be delayed. And one more thing, if you are completing this addition, then only the next addition can be possible. So in a normal way, serial processing can be used. The main reason is the carry can be propagated here. To make a parallel processing and separate this carry generation, that can be done by carry save addition. Let's see this concept by one example. And one more point, this carry save addition only suitable for more number of bits. Suppose if we multiply two 2-bit numbers means the normal multiplication is better. But for only understanding purpose, I can explain this concept from small numbers. Here I write these two numbers as 3 bits. So I have three partial products. I can take these partial product as A, B, C. These three numbers can be added, the sum can be generated, carry can be saved separately. Then these two numbers can be added, finally get the product. That can be illustrated here. So for this partial product, first I add these numbers. So the sum is 0, carry is 0. So the carry can be written separately. This carry cannot be propagated to the next bit addition. So the generated carry can be stored in a separate place. Now you can add these three numbers. The sum is 0, the carry can be stored here. Then you can add these three numbers, sum is 0, carry is 0. Add this number, sum is 1, carry is 0. The important point is you can add these values parallelly. The sum and carry value can be stored separately. Then finally you can add these two numbers as in normal way. Then you can get the product value. Now I can move to the 4-bit numbers. The same number can be represented as 4-bit number. Now you can get the 4 partial products. So these can be taken as A, B, C and D. First I add these two numbers and I get S1 and C1 separately. Then I can add these two numbers, S2, C2 can be get separately. Then I add S1, C1 with S2, I can get S3 and C3. Then these three numbers can be added, you can get S4 and C4. Finally, these two numbers are added and get the final product. So this is the first step and this is the second step. This is the third step, fourth step. At fifth step, you can get the final product. The first step can be illustrated here. So 0 is the sum, carry is 0. For these two numbers, 0 is the sum, carry is 0. For these two numbers, 0 is the sum, carry is 0. For these two numbers, 1 is sum, carry is 0. So in this way, sum and carry can be calculated as S1 and C1. In step 2, C and D can be added. You just note this precision that can be followed for this addition. When we add these two numbers, you can get sum is 0, carry is 0. So in this way, you can get this result. In step 3, you can add S1, C1 result with S2. So the new sum and carry can be calculated. That can be represented as S3 and C3. So in fourth step, S3, C3 added with C2. That can be shown here. Then you can get S4 and C4. So in step 5, you can add these two numbers in normal way. You can get the final product. In third example, I can take some bigger number. Let's take two 6-bit numbers. I consider these two numbers are unsigned numbers. So I can write the actual binary value here. For this 6-bit, we can get the 6 partial product. That can be denoted as A to F. So first we group these partial products. So first I take A, B, C as S1, C1. D, E, F as S2, C2. Then S1, C1, S2 can be produced S3, C3. These result with C2 produce S4, C4. These result can be produced final product. So first I take this ABC value. That can be calculated here. So 1 is sum, carry is 0. 0 plus 1, 1 is sum, carry is 0. 1 plus 1 10, carry is 1. 1 plus 1 plus 0 is 10. So sum is 0, carry is 1. So in this way you can fill this S1 and C1. In step 2, D, E, F can be added. You can use this same precision for this calculation. Then you can get S2, C2. Then step 3, you can get S3, C3. Then step 4, you can get S4, C4. Then finally, you can add these two numbers and get the final product. In your examination, after finding this result, you can convert it into equivalent decimal value. Then write the result as a sentence. So in this way, the carry save addition can be calculated.